Hello, I was working on this last week. It's a JVC high definition video recorder that records in a fairly unusual format, and it can do so on this size of tape. It's the only machine that can do so, making it a format of one machine, which I find fascinating. So I tried really hard to repair it, but I failed because I didn't have service manuals and because there had been some damage to the unit done by somebody else in the past. I made some progress on repairing the damage, but without the service manuals came to a sticky end. Well, one of the great things about YouTube is people can come to my rescue. So Alex from Germany, I'll include a link to his YouTube channel because he's an expert on audio for broadcast. Also Henrik from Denmark have both sent me the service manuals, and they're subtly different, so I've got lots of information there. So now I can have a fighting chance at least working out a little bit more about what's wrong with this machine, but it's going to be pretty in-depth. Let's get stuck in. The machine we're working on then is the BR-HD50, and I also have, just for reference, this works, a BR-DV3000 that uses the same mechanism, but inside it's quite a different machine, so it can be useful for referring to things. And now we have the schematics. Well, there's a failing of both of these machines in that when we're looking at the output from the video heads, you need a special board to plug into the back, which will give you the signals you need, the head switching and RF output from the head amplifiers. However, with the schematics, I think I've worked out where those signals can be recovered elsewhere. So when I first got this machine, we found that the flexi cable from the output from the video heads, where it connects to the head amplifier, it had been severed. And last week I made up a very small section of replacement flexi cable to go into a connector, which I had made from a scrap camcorders flexi cable, and soldered that up, and I was fairly convinced that that's working, but with the service manual I can do some more tests on that. Then the output from that, if it's connected and working, goes to a small chip which is a head amplifier, and that should give us a FM envelope. And another signal that's required in order to make much sense of that FM envelope is a head switching signal. That's kind of available somewhere else on another board, and it comes into the head amplifier via a inverter chip, so we should be able to pick up that signal one side or the other of the inverter and also the FM envelope, and I'm suspecting we'll get nothing, and then we can just start to investigate why that is. So we've got plenty to get on with, but first thing I think we'll have to do is get the deck out at least a little bit so that I can gain good access to that head amplifier circuit. So we'll start by gaining access to the machine again. Okay, this is the deck here, and this chip here, which should have a metal screening can above it, is the head amplifier. So can we gain access to the signals we want from here, or do we need to take the deck out? The first thing I can do though is check on the connector here, that white connector which has got the flexi cable that we repaired, that we see something approaching a short circuit from the windings for the rotary transformer from the head, and that we don't get any short circuits to ground either. So I can do some DC resistance tests along that connector first, make sure that the repair to the connector is probably working okay. Looking at the service manuals from JVC, I see the connector we're looking for is called Rotaly Trance. That makes a heap of sense. I think it's supposed to be to and from the rotary transformer, but they obviously don't proofread their manuals, do they? I'm going to struggle to be able to probe this, and certainly to be able to show it to you with the deck in that position. So I'm going to see if I can just pull the deck up a little bit to gain enough access to the back of that board. It's a nuisance because it makes it harder to load and unload tapes, but we're just going to have to, I think. So we have a pretty good view of the connector we're interested in. I think we can see which is pin 1 and 8, and okay, so 1, 4, 5 and 8 are all ground. I'm sure we'll find that's the case, so let's just prove that. Okay, so pin 1, ground, 4, 5 and 8. Okay, Now we should see a low resistance, I think, between pins 2 and 3 and between 6 and 7. So we'll check those and then we'll worry about whether we have any shorts. So between pins 2 and 3, might be used to pick them up on these resistors. Okay, I'm getting something like an ohm or something between those. And similarly between 7 and 8. Sorry, 6 and 7. Okay, and let's check that none of those are shorted to ground. Oh. They're all shorted to ground as well. I wasn't expecting that. So that's a concern. Should I take the flexi cable out and just see where that grounding is coming from? It could be normal, but I wasn't expecting it, I don't think. Now there's a risk removing this flexi cable, so I'm suitably scared about what might happen. Okay, that's disconnected that. What do we see now? Do we still see these points here? I mean, they're still going to be ground, but what about these? No. I think the cable just popped itself back in. So, is there any possibility that I've managed to short everything to ground in a great big mess over here? Well, I don't believe so, but we will have another look at this flexi cable under the microscope, just in case I've messed something up since last week when we worked on it. Let's get it reconnected first. So I'm going to have to get the board out a little bit to give us a decent view, I think. So let's look at it in some detail here. It looks a lot better through the optical viewfinder than it does, of course, through the camera, but never mind, let's do what we can. So here's our first connection. This is a ground connection on the end, and our big concern being that we mustn't have any short to the head connection next to it. And I can say with some confidence there's no shorts there. Then we have the head winding, these two connections. Again, no shorts between them, nor to the ground point in the middle here. There's no shorts between those, the head winding there and the ground point in the middle. The ground point in the middle does have a short between these two contacts because that's the diagram. They are connected together. And then we have the next head winding pair. And I can get my blade down between there. There's no short there, and there's no short between the windings. It's not that clear on your camera, on the camera view, but it's much clearer optically. And then finally, the end winding and the ground connection at the end. No shorts there either. I can say that, but you probably can't see it so much on that view because everything sort of shines and it all looks the same. Whatever I do with exposure, it never seems to give you quite as much detail as I've got here. There we go, it might be a little bit better. So hopefully you can see there that all the connections are made and not shorted. There is a hazard that there's a risk of a short to the screening at the top that may have happened when whoever it was severed the cable. There might be a short hazard along the top. I think there's a screening film. Here's a risk of a short out to ground here. This is a screen, I think. See this colour here? That's a screening film, isn't it, I think? And there's a possibility that we've impacted that with our soldering. Ah. I hadn't considered that before. So it may be that we're shorting out our heads. to this ground. Oh, that could be really difficult to fix. Yeah, there's distinct possibility. I don't know if you can see this. Again, it's not easy to see on the camera, but this area here is a screening film, I think, another layer on the flexi cable, and I think our wires may have gone through the insulation on the top of that and potentially shorted us to ground. So how could I fix it? Well, I could just take my blade along here and see if I can cut the excess off the end of my wires and keep it away from here. I think that's my best shot. Give that a go, shall I? This is pretty scary. I think we had a problem. The screening layer on this cable here was impacting my connections, and I think was being pushed down onto the tracks as well. So where this had been cut back by myself or whoever damaged the cable in the first place, it had been touching these tracks. Well, it doesn't matter about this one, it's ground anyway. So I've pushed it back with a blade, and I think we might have got what we're looking for now, which is to say, check my multimeter, the ground connections are all common, and we have continuity caused by the rotary transformer across the individual windings, but no continuity now to ground from those windings. Got it on the contact at the end, but not the windings, and the windings themselves are making contact. So that's all looking good. Let's just check that we have continuity on the PCB as well, and that being the case, it's worth refitting the deck. Okay, I've refitted the flexi cable, these two control cables and one power cable underneath. Let's power up the machine. We know that it shuffles around a bit, gets a little bit confused when there isn't a tape in there, and we're just going to live with that for a minute. Put a tape in. And press play. Anything happening? Play, please. We did get some meaningful movement on there. Remote local switch, right? Hit play. Right. We appear to have a lot of block noise, but we do seem to have connection to the heads. So we've got a long way to go, but we've come a long way from where we were. Maybe now we're back to the original fault on this machine, which caused somebody to take it apart. Bear in mind also we don't have the screening can over the head amplifier at the moment, because there isn't one. I'm going to have to make one up. Lots of block noise. But it's coming along. Let me show you what I've hooked up here. I think I found the signals we need. On this pin here, we have HID, which is, I believe, the head switching signal as it comes into this head amplifier board. It actually goes through a inverter before it goes to the first chip there. And then over here, I've put the probe, the multimeter probe, oscilloscope probe, into what I believe is the envelope output on pin 14 of the next connector over. So if I've done this correctly, when I hit play on here, I should be able to get on the oscilloscope good envelope and head switching signals, and we can get some idea of what's wrong. And I've changed the tape for a DVCAM tape at the moment. If I've set this up correctly, I should have head switching signal and envelope signal coming out of the deck here, going to this oscilloscope, and I've got a DVCAM tape in there, which is still playing with errors just like the miniDV tape was. So let's have a look at the envelope compared to what it should be according to the service manual. So on channel 2 I should have the head switching signal. What mode is that in? DC. Looks like it's AC coupled. That's just a horrible signal. Well, it's an ugly looking signal on the head switching, but maybe that's right, and it doesn't matter. It should be giving me the RF output on channel 1. Well, if that's an RF output, it's a horrible looking thing. Looks like this massive deck alignment. Let's try picture search. Pity I haven't got remote control. Okay, so it's not surprising we're getting errors when you look at the state of the RF envelope. It actually looks better in reverse picture search. And actually in reverse picture search the machine seems to be working fairly well. We have noise rolling through it, which is probably just mains hum from the setup. I'm not going to worry about that for a minute. And forward picture search as you expect, but in play we're getting multiple misalignments, and it's much closer to being correctly aligned in reverse picture search. So it kind of looks like somebody might have been playing with the tape guides, or there's some other reason that the alignment is way off. Okay, that's really interesting, isn't it? It tells us that there's something wrong with the deck itself. Either the alignment of the deck is completely messed up, somebody may have been playing with the tape guides, or there's some other reason that it's way out of alignment, such as a problem with back tension or another defect that's causing the tape to weave. So we're going to have to refer to the service manual some more. One thing I was thinking, is it reasonably consistent when it's playing? Do those misalignments stay in the same place, or are they wandering around everywhere? If they're wandering around everywhere, then that implies that the tape is weaving up and down the guides. Let's have a quick look at that again. It is stable, fairly stable. Look, those misalignment marks are staying where they're put. The machine is trying probably to do auto tracking, which will cause them to move a bit. But I don't think we're looking at tape weaving. I think the tape is consistently wrong. Also, if I hit pause, you shouldn't get that many little envelopes through pause. You should only get a few, and I can refer to the service manual to how many, but not that many. So I'm definitely feeling like the tape guides have been got at, or there's some other reason the tape is completely out of alignment. So here we are again looking at a miniDV tape, and we can see the FM envelope with these multiple mistracking. You can tell it's in and out. If I select reverse picture search, in fact we get less mistracking in reverse picture search, but there's still some at the end. So it's all, we've got a head clog now, that's not helpful. So we've got a massive tape alignment error. Alright, so let's look at the deck a little bit more. We would expect to see, if somebody's been twiddling, right, if somebody's been fiddling with the input and output guide posts there, then the tape would be hugely shifted up or down on the head drum, and you would probably see such a massive alignment error. Let me see if you can see the tape. You can see the head drum there, and it doesn't look massively misaligned. You know, it doesn't look like it's way off, as massively out as it would have to be in order to be this mistracked. So that makes me feel that maybe it's not down to somebody having twiddled the guideposts here and here. But it's not impossible. It isn't as though the tape is weaving all over the place. It looks stable. I just want to check that it has fully laced, because if you've got a position where the lace had not quite completed, then you might get this sort of error. So let me just confirm that the guides are fully in place at the end. The trouble is, with this big plate on the top, it's a little bit hard to see. Well, from what I can see, the guides are fully in their proper, fully laced position. It's not like they're half laced. So that's the supply spool, supply guide there, and this is the take-up side. And they both look fully engaged. Is there anything else that's desperately wrong with the tape path? You know, the tape looks like it's sitting properly on the bottom of the head guide, and it's not terribly easy to see on the camera. Again, it's much easier to see in real life. So there's the tape sitting on the head, and you wouldn't say that it's, you know, massively wrong. It looks like it's sitting on the bottom shoulder of the head drum where it should be. So is there something wrong that's causing the tape to not be in the right place now? Let's see if my tape guide adjusting tool fits these. I suspect it's too big for them, actually. Just get a feel for whether this tape guide is incorrectly set. Yeah, I'm just going to have to use an ordinary screwdriver. I don't think that's going to fit that one. If anything, I'd say the tape is a little bit high. So looking at where it's set presently, it's over there. I'm going to try adjusting it down and see if anything improves. I've adjusted it 2 turns anti-clockwise on the take-up side, and it doesn't have as many mistracks in it. Okay, after that adjustment, it is slightly better. It's only got 2 total, 3 maybe, total mistracks. So I believe this is the exit side and this is the input side, and we've got the exit side is getting closer. The input side, we've still got 2 mistracks. So having made some adjustments to the exit guide and the input guide, so we've got a decent-ish chunk of envelope here and 2 or 3 mistracks on the input side, so I can't get it any better than that. There is another tape guide on the input side, but if we have a look at that one, I think it's still got a blue sealant on it, and it doesn't feel sloppy like the other 2. So I don't think anyone's been fiddling with that one, so we won't twiddle that. I suspect that somebody's been fiddling with the tape guides because they've had another fault with the deck and didn't know what else to do and started twiddling tape guides. Maybe it's not fully laced or there's some other problem with it. So let's compare it to our known good DVCAM deck and see if there's anything obviously different about what it looks like when it's fully laced. Okay, this is a DV3000 deck, and you can look at where the posts are here relative to the deck when it's in a fully laced condition, and I've just switched it off when it was fully laced. So you can see where those guide posts are and that they have reached the end of their travel on the loading cycle. And now comparing that to our target machine here, and yes, the loading cycle is completed on this too, we can see that those posts are in just the same position on this machine as they are on our DV deck. So we can say with some certainty that there isn't a mechanical problem with the deck achieving lace up. And we also have tried adjusting these guides, but we haven't fiddled with the sort of pre-guides. There's a guide here and actually one on the exit side. Both of those have not been twiddled by anybody, and they have a blob of blue sealant in them. So I don't believe that they've been fiddled with. Now, it has to be said, there is no blobs of blue sealant in the DV3000 deck either. I think there are possibly, as there are on Sony decks, there are possibly grub screws at the bottom of the post, which should be done up once the post is set, the alignment is correct. Not sure if that's true on this model, but certainly the guides were very sloppy on this, our machine we're working on. So I think somebody had been fiddling in there, probably because they were trying to fix some sort of alignment fault. So we still have this issue with our target machine here having a misalignment of some sort in the tape path. And we've been monitoring that using the signals from these connectors on the oscilloscope. It's a little bit easier on an analog video recorder, VHS, Beta, what have you. When you get misalignment like this, you can kind of see it in the picture. We're working just on the RF envelope shape, but it's definitely suffering from mistracking. You can see that the signal is disappearing down to zero 2 or 3 times, especially at the start, which is the input side of the sweep. But I don't know the reason. If you're an expert on DV decks, or this particular type of deck especially, do let me know. I'll do plenty more content on audio and video technology in the near future. Bye for now. I want to say a big thank you to patrons over on Patreon who help support this channel. And the reason I mention it now is I've got something coming up in the next week or two, which is something that's going to cost maybe £150, £200, something like that, of my money, but is not going to benefit me or my business or even my channel particularly at all, because it's for helping people to repair equipment, but not equipment that I have here. So it would be really good if a few people could maybe chip in on Patreon to help support that little project, which I will show you in the next week or two.